In my life, I would consider myself two things. First, an engineer, and second, a musician. That's why, throughout the entirety of reading The Design of Everyday Things by Don Norman, all I could think about were guitar pedals. Guitar pedals are specialized tools that change the way your guitar sounds. Each one changes the audio, but they also have a physical form, meaning that they can be analyzed through the 7 fundamental principles of design. Some guitar pedals are beautiful, while others are a little ugly. However, today what matters is that I will be reviewing my 2 favorite guitar pedals through the lens of human-centered design. The first guitar pedal is the Proco Rat. The second guitar pedal is the Zoia, designed by Empress Effects. I will be comparing and contrasting these 2 pedals through the 7 fundamental design principles. The first design principle is known as discoverability. This means when we look at the product, what can we do? Instantly, just by looking, what can we tell? Well, we see that there's a button here, a very nice stomp switch. We see that there are some knobs we could twist. And in the back, we see that there's an audio jack for audio in and a jack for audio out. We also see that there is a 9-volt input if we plug it in. Now, when we turn on the Rat, when we use the stomp switch, we could see that there's an LED that turns on and off, signaling the state of the machine. This is good discoverability because we're able to tell what state the machine is in, and we instantly know what we're able to do. Now, if we look at the Zoia, there's a lot more information we need to process. There appears to be a single knob, which we may also click. There are 3 stomp switches. If we look in the back, that is a lot of ports. There is a lot going on back here. Again, if we look in the front, we have a matrix of push buttons. They're tactile, we could squish them. Nothing happens right now. Over here there's more buttons and there's a screen. If we plug in the Zoia, we're greeted with a loading sound through this nice little display screen. If we wait for that to boot, which takes a while, we're greeted with a lot of different colors. The screen says Duck Friends. What's going on? Immediately, it is not obvious what state the machine is in. It is also not clear what's going on. You could press the buttons, but what do they do? Now, through my experience with a pedal, I understand that it is actually quite difficult to tell what state the machine is in and what exactly we're able to do with all of these buttons. And in my opinion, that makes this pedal have bad discoverability. The next fundamental design principle is known as feedback. Feedback describes if the user knows what state the machine is in after they have made a change. So with the Rat, if we hit the foot switch, we can see that that red LED does light up. And in our culture, on LED means on. That means the pedal is working. So through this feedback, we see that the foot switch has the effect. How about by twisting the knobs? Nothing happens, on or off. However, if we send an external signal such as a guitar, we'll be able to tell what these knobs do. And from that, we can deduct the feedback of the instrument. Here it is clean. And now, with the Rat engaged, we could hear that the volume knob changes the volume. The distortion knob makes it sound more aggressive. What does the filter knob do? It controls off the high ends, and let's see if we can do that. Back just a little bit, and it does get smoother. Now the controls are simple. And the feedback is instantaneous. That means, in my opinion, the Rat satisfies feedback perfectly. Moving on to the Zoia, when we consider feedback, let's examine it. So here we see 3 stomp switches. If we hit the stomp switch all the way on the right, instantly it starts making noise. We see that these red buttons turn green, implying that it is on. We could also hear the audio. If we hit this middle button, it's not so obvious what's happening, but I believe it's changing which setting the pedal's in. There's no auditory feedback, so it's difficult to know exactly what is going on. If we hit the leftmost button, we see a slight change in the color pattern. Keep an eye on this LED. When we turn it on and off, the LED changes. Now we can also hear the auditory change in feedback. Let's start clicking buttons. Usually when you click a button, you expect an instant feedback and you know what's happening. When we click a button here, we get a little bit of information on the left of the screen. It's not instantly obvious what is actually happening. In order to know what is happening when you click a button, you have to have a very in-depth understanding of the Zoia and the setting it is currently in. For that fact alone, I believe the Zoia does lack quite a bit on feedback. It is just difficult to understand and difficult to use, especially for beginners. The third design principle is known as the conceptual model. The conceptual model is how the product describes itself in an intuitive way to the user. The conceptual model helps the user understand what it is doing and why and how. Now with the Rat, it's not very obvious how it works. You gotta actually have like a degree in electrical engineering to understand what's happening. So how it works is a mystery. The internals, complete mystery. However, it works, and we know that it works. And we know it works by twisting the knobs and different sounds. If we want, we could watch YouTube videos to develop a more thorough understanding. However, to use the product, I don't think a YouTube video is necessary. I don't even think a manual is necessary. Just through a very quick trial and error, you could tell exactly what you want and how you want it with the design. Now for the Zoia, the conceptual model, again, is a little less obvious. One of the tools used for conceptual modeling is the use of iconography. Here at the top, we can see a control panel. Each of these symbols are very intuitive and are recognized in Western culture quite thoroughly. Here we see 4 arrows symbolizing movement. If we select a module, we are able to hit the command, click move, and now we're able to move it wherever we wish. Next, we see the copy button. It looks like 2 pieces of paper copied together. This is funny because it seems to be using like typical computer software symbols. So using computer software symbols again on hardware, which was inspired by hardware in the first place, is very fascinating, like full loop. We're able to copy it quite easily. We're able to rename it, as in, you know, drawing on the piece of paper. We have a trash can symbolizing deletion. We have a star to favorite things. We have an eyeball so you could get a more in-depth view of the signal. You could save the signal and you could randomize the signal. Now, an important factor of the conceptual model is allowing the user to feel in control, giving them enough information that they feel in control. Another important factor is how simple the conceptual model can be. The emphasis is on simple. Don Norman says it has to be simple. Unfortunately for the Zoia, there is no simple way to describe this pedal. And I believe that's bad design. I believe there should be an easier way to describe this pedal in a way that makes sense. Personally, just the tutorial book, what's that called? The reference guide, the guidebook that it shipped with was not enough for me to clearly understand. And because of that, I never had a strong sense of control over the pedal. With good design, you want the user to feel in control of the design. And with the Zoia, I just don't. I have watched plenty of YouTube videos, and after hours and hours of research, it's still a struggle, right? This feels like a machine that was designed for people with a bachelor's degree in computer engineering. And this is not designed for humans. You know, this is designed to be used by other machines. The fourth design principle is affordance. Affordance is a little difficult to understand, but it's a relationship. An affordance is a relationship between the user and the product. An affordance we see here is that we're able to twist the knobs, we're able to click the buttons, we're able to unplug things, plug things in, we're able to send sound in, and expect some sort of change in the signal out. I'm also able to pick up the pedal, I'm able to throw it, I'm able to sell it. There's a lot of affordances you could do, but the main intended affordances were just on, off, twist the knobs. The Rat is a very simple design when it comes to affordances. There's not much you could do with it, but what you can do with it matters. Now, so far you might be believing that the Zoia is a terrible pedal. I bought this for $350. Its market value is $500. The Rat's is $75. So you might be asking yourself, wait. You spent $500 on this pedal and $75 on the Rat, but the Rat has so many more affordances. Why? Well, check it out. The Zoia can not only can it copy the noise the Rat makes, but it can do so much more. The Zoia can also sound like this. And as we previously discovered, it could also sound like this. This is because the Zoia is modeled after what is known as a modular synthesizer. A modular synthesizer is a huge block. It looks like a very early computer and can be used as a computer. The Zoia itself is actually Turing complete, meaning that you could write actual programs on it. One day, with enough space, you will be able to write Minecraft on the Zoia. And that is just a crazy, phenomenal idea. That means the affordances are only limited by your ability to comprehend what is happening. I think that's really incredible. The fifth design element is the use of signifiers. Don Norman describes signifiers as anything that gives information describing affordances to the user. For example, we see the volume. We assume that the volume label describes the knob. Here we could see notches, describing as if you turn it to the left. Left is less, right is more. If you look closely, you could tell there's a little tiny notch on this dial, pointing which direction the knob is, to what degree it is turned. We also see that the minimum value is marked and the maximum value is marked. the distortion is labeled, the filter is labeled. At the top, the audio in is labeled, the 9-volt DC power port is labeled, and the audio out is labeled. The only thing that is unlabeled is the foot switch power switch. For the Zoia, as we have discovered so far, it is quite the complicated piece of technology, but we could still see that it uses some signifiers. In the top row, we could see we have the move, the copy, the write. We previously discussed those. We also see that each button is labeled with A, B, C, D, the alphabet. There's also some back buttons, a question mark button, some settings buttons as well. Each of the foot switches are properly labeled. Each of the buttons over here are labeled. We got a page, a piece of paper with a left arrow implying page left, meaning go back a page. In the back, ignore the cable mess, I suppose. We have the inputs properly labeled left and right. The output is also properly labeled left and right. Power port is labeled with proper rating. We have micro SD slot labeled, MIDI labeled, and a control port labeled. So far, all the physical features of the Zoia are very thoroughly labeled. But then, it brings up the question, what about the grid? What about the matrix we're looking at here? Well, that's where this little LED screen comes into play. Because it has an LED screen, the Zoia is able to use many, many more signifiers to better communicate what is happening. Here we have text saying we're doing something. It's a select category. If we go to audio modules, we have a long list we could scroll through, and it describes what the module does. We could click done. And of course, in my opinion, this doesn't fully explain how to use the matrix. The matrix is still very, very confusing to beginners. However, I think Empress Effects did a wonderful job giving enough signifiers to get a very basic grasp of what is going on. I think the use of the LED screen really helped communicate a lot of the principles of this pedal. So that is not bad. Not bad design. The sixth design element is mapping. Mapping is used to describe the placement of the controls. Good mapping is typically associated with light switches. Typically on the light switch board, the closest lights are controlled by the closest light switch, while the farthest lights are controlled by the farthest light switch. It's very intuitive design because it makes sense naturally. Or if you've ever seen the seat controls in a car, typically you have the controls in the shape of a seat, and that just makes sense to the human brain. That just gets it flowing. Now, if we look at the Rat, how mapping applies to the Rat isn't so obvious. I don't think there's a lot of mapping going on here, just because it is such a simple pedal. It's not very complicated. There's not much going on for it, right? However, I do believe that perhaps the mapping is related to the order of the knobs. From my understanding, perhaps the first stage in affecting the tone. Okay, this is like all like electrical engineering stuff. So it doesn't really make sense to the basic person, but it's like you don't need to know this stuff. First, the sound is boosted and distorted. Then a low pass filter is applied, and then finally the volume is controlled. So perhaps the effects of the pedal are executed in this order. And that makes sense. Of course, I'm saying maybe, probably, because I'm not entirely sure how the Rat works. But it would make sense if the mapping was actually done in that manner. Now for the Zoia, this is neat. The grid here is, imagine it's mapped out to an actual like physical component. I'll show a picture on the screen now. So there's like these studio utilities, right? They're just like giant guitar pedals, I suppose. Everything's a giant guitar pedal, but they're long and they're flat. Kind of like in the shape of a horizontal Tetris piece, right? Now we could imagine the matrix as an actual like physical location. We could place these modules and they are flat. They are long and flat. And the controls of the Zoia actually give you an option to control the mapping, of course. So even in using the pedal, you have to be the designer. For example, typically what I prefer to do is left to right, top down. And that's just a very intuitive mapping. It makes sense to me. And you could connect the components along in any order you want. But I typically like doing, like I said, left to right, top to down, because that symbolizes a more human, actual real world physical thing you would do, where you would have your equipment, like I said, left to right, top down. The seventh and final design principle is constraints. It's actually fascinating because when I think of design, I think of more is better. But Don Norman clarifies that you want kind of like less design, right? So the RAT itself, there's so many things the electrical circuit could be doing in there. And if the user had complete control over every single detail of the circuit, the user would instantly be overwhelmed. That's why I believe it is good design that they only gave you really 3 parameters to work with. Only 3 knobs. It's not overwhelming to use, right? I guess you got 4 if you count on and off, right? Not complicated. Yeah, no constraints. There's a very limited there's nothing in your way. I guess the only thing that's actually constraining you from accomplishing all your dreams with the Zoia is the fact that it's, not infinitely large. There is only a limited amount of space the program can live on. But I guess also because it is Turing complete, there's literally no other constraints involved here. I think because it isn't constrained, it's very overwhelming for beginners. Now it brings the question, is this good design or bad design? I believe these products fulfill 2 different roles, right? I mean, the RAT, this is like, you don't need to be specific, right? The whole reason why I bought the RAT was because it was badass, okay? That's the only reason. The reason why I bought the Zoia was so I had infinite possibilities I could program on this thing, right? So I believe in this specific context, the constraints aren't really necessary. There's nothing is lost by having more in the case of the Zoia. However, that does come with the trade-off that it is less user-friendly, and I guess by that definition, poor design. I'm still working with this idea, trying to like figure out the balance between is this good design or not. I don't know. Still something to ponder upon. And another aspect I wanted to cover that Don Norman covered in the design of everyday things is how the user feels looking at the product, the actual aesthetic of the physical design. Don Norman was, what was he? He is a master of cognitive science. He is an expert. He understands it. So to him, the physical reaction, the emotions the user feels looking at the design matters greatly. When I look at the RAT, I don't really feel much. I don't think there's a lot going on. I think the black and white color scheme is very simple. When the red LED is on, that's kind of like an aggressive emotion. I think it's fulfilling. The audio, the audio aspect is pretty aggressive too. So I think that's good because that's what the Rat's job is to do. It's to give that aggressive bite that's found in a lot of rock music. The Zoia, it's like, I'm disappointed by the physical design. When I look at the Zoia, I don't feel like wonder, right? Looking at a few of my other guitar pedals, for example, the Walrus Audio Julia, look at this design. I feel so many complex emotions looking at this design, right? It fills me with a satisfying feeling looking at it. Or take the Earthquaker devices underneath. That's a wizard in a crystal cavern. Compare that to the Zoia. It's like, it's colorful. I mean, like when it's on, when you have a program on it, it's colorful, right? But otherwise, it's like this ugly black box. It's just not satisfying. It's not beautiful. And in the book, Don Norman mentions that attractive works better, right? Tools that look better, people perceive them as being better. And I think that's very important to consider when looking at guitar pedals, right? The actual graphic design. And I don't know. It's like, I think these two pedals are equally ugly, but I think the Rat has a more satisfying design just because it doesn't need to be a complex design because it's not a complex pedal. The Zoia, it's like, it's disappointing. I wish the graphics were better. And that's all I gotta say about that. To reiterate, Don Norman believes in human-centered design, meaning that the product should be completely designed with the human's use in mind. That sounds a little redundant, but a lot of designs that Don Norman analyzed focus on how a machine would use the design, and that's just not the case. Again, the 7 fundamental principles of design were discoverability, feedback, conceptual model, affordances, signifiers, mappings, and constraints. Analyzing these principles, I believe that the Rat beats the Zoia in terms of design. I believe the Rat is just better designed, more friendly. It is simpler, and it conveys its purpose so much better than the Zoia does. But then again, I didn't buy the Zoia because it was user-friendly. I bought the Zoia because of what it can do. Thank you for watching the video. I appreciate you, and I hope you have a good day.